Hi there. A random sample of 200 is taken from the adult population of a town and classified by age group and preferred type of car. The results are given in the following table. And here we are, and we've got hatchback, estate, convertible, under 25 years of age. We've got 32 here, 11, 17, and so on. Now we need to test at 5% significance level whether preferred type of car is independent of age group. Now, in doing a question like this, the first thing I would do is I would compute the totals. And if I do so, 32 plus 11 plus 17, 60, and for the second row I got 75, and then 65 for the third row. Add them up, you get 200, and for all the columns you do the same, and you should be able to get 108, 51, 41, which sums up to 200. Next is I want to find the expected values. Okay, so how do we do that? The expected values for hatchback, here we've got 60 and the total here is 108. So what we do, we take 60 into the calculator times 108 and divide it by the grand total 200, and that's going to give you 32.4. The next thing is 60 times 51, so 60 times 51 over 200, and that's going to give you 15.3. Next is 60 times 41, and then of course you divide by 200, it gives you 12.3. And so if you add these up, you should be able to get 60. So let's move on and now to see 75 times 108, and then divide by 200, that comes to 40.5. Then you've got 75 times 51 divided by 200, 19.125, and then you've got 75 times 41, all of that over 200 comes to 15.375. And again, if you add these up, you should be able to get 75. So you can check this out. Next is 65 times 108, and that comes to this much divided by 200, and you get 35.1. The next one is 16.575, and then you got 13.325. So the next thing is to build another table, and we're going to take all our observed values, and I've listed them now down here. So that's 32, 45, 31, 32, 45, 31, 11, 24, 16, 11, 24, 16, 17, 6, 18, 17, 6, 18. And then you just do the same for the expected values. You match them. You got 32.4. Okay, and then you've got 40.5. Okay, so 35.1, 15.3, 19.125, 16.575. You've got 12.3, 375, and finally you've got 13.325. So we're going to use this formula there, and the first thing you do is you take 32 minus 32.4 and you square that, and then you divide by 32.4. I mean, just go according to the formula. And so from here I've got 0. This is giving me in standard form, which is 0.00494. You do the same for the next one. 45, take away 40.5, and all of that to the square, and you divide by 40.5, and you get 0.5. Next is 31 minus 35.1, and you square that, you get this much, and you divide by 35.1. It's here. So 0.47 sum. I'll put it to 5 decimal places according to my calculator here. So next is 11 minus 15.3, and you get all of that. So you square it and you divide by 15.3, and that comes to 1.2085. So 1.20, let's say 897. 0.85, that's 49, so 50. So I say 50, yes, because take 1 here, should be 50. 20850, that's cool. So we're going to do all of that in just a sec. So now from this table, after having added all this sum, each and every of these numbers, I get the sum here, which is my chi-square. So this is my chi-square value, often written as this with the Greek letter chi-square, and that's going to be 12.6 to 1 decimal place. Where do we go from here? We need to test at 5% significance level whether or not there is an association between the type of car that a person would choose according to his or her age. Right. So at 5% significance level, my chi distribution value, I need the chi distribution table. 5%, so I'm looking at 1 minus 5 over 100. So that's going to become 1 minus 5 over 100, 0.95. So we're looking at 0.95. Okay, so, and rather my chi value, so chi square. And what about my degrees, V degrees of freedom? So V degrees of freedom would be from the columns and the rows. We've got 1, 2, 3, 1, 2, 3. So I've got then 3 minus 1 times 3 minus 1. So I've got my degrees of freedom as 4. So therefore that's going to be 4. Basically this should not be T there, it should be the chi distribution, so the chi square. Alright, so we're looking for 0.95 with degrees of freedom as 4. Right, so let's take a look. Degrees of freedom is 4, and 0.95 is here, so I got 9.488. That's my value. So 9.488. So what are we saying is that the chi-square with degrees of freedom 4 is going to be equal to 9.488. Now this value here is our significance level, and the critical value, that's the critical value or region. So if you look at your chi distribution curve, it's going to be something like this. Now let's suppose that this 9.488 is here. So all that region there is our null hypothesis, HO. And over here I've got my chi-square value, which I computed from the observed data, and that was 12.6. As can be seen, the 12.6 is greater than 9.48, so it's outside. This value here, the chi-square value, which is 12.6, is greater than the significance and the test statistic, okay, than the chi statistic value of 9.488. That means it falls outside. The critical region. So we reject HO. which basically concludes to there is no association. Because remember, if we were to define a null hypothesis for this problem, I would rather say that, just bear with me a second please, I need to put this up. Okay, so a null hypothesis is that there is an association between car type, preferred car type, and age. Between car type and age. And our alternative hypothesis is that there is no association, no link. Let's write this carefully. No association between car type and age group. So what are we trying to say in context? So therefore now, when we look at this, 12.6, all right, is greater than 9.488. So since 12.6 is greater than 9.488, we reject HO. So that means there is insufficient evidence to suggest that car type and age group are not independent. That is, there is no association. All right, so that's about it for this question. Take